Hey pilots, welcome back to chemistry. This is Mr.pHong, and today I'm going to show you how to determine the empirical or simplest formula from percent composition of a compound. Let's say you have a sample, an unknown sample that you don't know what it is. You send it through an analyzer, and the analyzer tells you that the elements that this compound has are silver, clocking in at 63.5%, nitrogen 8.25%, and oxygen 28.25%. But you don't know what the chemical formula is. You need to find what we call the empirical or simplest formula. The first thing you want to do is you want to write a shell of the formula. That is silver something, nitrogen something, oxygen something. What goes inside these blanks over here? The number of moles of that element, and it has to be whole numbers, and it has to be the simplest form. Kind of like simplifying fractions. Well, can we put these numbers in there that we see in the given, 63.5, 8.25, and 28.25? No, because those are not the number of moles. Those are the percentage by mass. Those deal with grams. What we want are the moles. So being that percentage is based on the number 100, what we do is we assume a 100 gram sample. And it doesn't really matter what size sample we take, because we know that by percentage, no matter what size sample you have, the percentage is going to be consistent. Any size sample is going to be 63.5% silver, 8.25% nitrogen, and 28.25% oxygen. So what we do is we assume a 100 gram sample just to make our life easy, and if we have a 100 gram sample, we know that the grams of silver are going to be equal to 63.5 grams. The grams of nitrogen are 8.25 grams, and the grams of oxygen is equal to 28.25 grams. Can we now put these numbers inside these blanks? No, these are grams. What do we want? We want moles. But if we know the number of grams of silver, should we be able to calculate the number of moles of silver? We sure can, using our good friend want is equal to have times factors. For silver, what do we want? Moles of silver. What do we have? 63.5 grams of silver times, and what's the factor, or where do you get the factor that relates grams of silver to moles of silver? That comes, of course, from our periodic table right over here. Silver clocking in at 107.87 grams. And so what we do, we say 1 mole of silver for every 107.87 grams of silver. And if you crunch this on that calculator that you bring to class with you every day, 63.5 times 1 divided by 107.87, we're looking at 0.589 moles of silver. We do the same thing for nitrogen. Moles of nitrogen is equal to 8.25 grams of nitrogen times 1 mole of nitrogen for every, and of course from our periodic table, 14.01 grams of nitrogen. Also, what I like to do is leave myself a little hint as to where I got these numbers from. This, of course, is from the P table. And if we crunch this out, 8.25 times 1 divided by 14.01, we're looking at 0.589 moles again, but this time it's nitrogen. And then finally, we have moles of oxygen, looking at 28.25 grams of oxygen times 1 mole of oxygen for every, and oxygen is 16 grams if you round it, 0.00 grams is equal to, and let's crunch this, 0.25 times 1 divided by 16, and we are looking at 1.77 moles of oxygen. Okay, what we want to do now is we want to now that we have the number of moles, we want to temporarily fill in the blanks with these number of moles that we just calculated. In this first blank, 0.589. For nitrogen, also 0.589. And for oxygen, 1.77. Okay, so now we have the number of moles, but are these whole numbers? No, they're not whole numbers. Are they close enough to whole numbers that we could just round this up to Ag1, N1, O2? No, not close enough. I would say if they're within a few 1/100ths of a whole number, that's close enough. But if you bought something for 58 cents at the store and gave them a $1 bill, would you expect some change back? Most certainly you would. So please don't just round that up to 1. What we want to do to get these to be whole numbers, well, as we know from math, if you divide each of these subscripts by the same subscript relative to each other, won't they be the same ratio? Yep, so what we're going to do is we're going to divide each subscript by the smallest subscript. So then we have Ag 0.589 divided by, and the smallest subscript is 0.589. We have N 0.589 divided by 0.589, and we have O 1.77 divided by 0.589. And so if we do the calculation, this of course comes out to be 1, nitrogen 1, and oxygen comes out to be 1.77 divided by 0.589, which comes out to be, wow, 3.00. Okay, and to clean this up, we don't need the ones there, they're understood. AgNO3. So this is our simplest formula, 1 mole to 1 mole to 3 mole ratio. So that's how you determine the empirical or simplest formula from percent composition. Good luck with the rest of your problems, and thank you for watching.